Thank you for joining us for this contributed session on subnational economic issues. My name's Stuart McIntyre from the University of Strathclyde, and I'm going to chair the first two presentations in this session, and then Martin Weale is going to take over and present, chair the final session, which will be my own presentation. So in this session, we've got Martin Weale, who'll go first, talking about small area estimation of price index weights, followed by Laura from the ONS, who will talk about subnational GDP estimates in the UK using administrative data. And then I'll present last on improving quarterly estimates of economic activity in the regions of the UK, picking up on some of our regional nowcasting work. The way this session will work, each presenter has half an hour or so. I'm sure you're all familiar now, we're sufficiently far into the conference with the arrangements round about this, but if you have a question for any of the presenters, please use the Q&A function, which you'll find at the bottom of your Zoom screen, to type a question. When we have the period for questions after each presentation, I'll call out your name. Sarah will unmute you as if by magic, and you'll be able to ask your question to each of the presenters. If there's any technical issues along the way, feel free just to let us know. Otherwise, as I said, each presenter will present for about 20 minutes, and then we'll have about 10 minutes or so for questions and discussion. So without adding any more to that, can I pass over to Martin Weale to share his screen and talk about small area estimation of price index weights.
Hello. So thank you very much for introducing this paper. This really brings together two strands of literature. On the one hand, I have been interested in some time on the issue of producing democratic price indices. On the other hand, the ONS has had quite an interest in promoting small area estimation so as to provide statistics for users that cover not just national aggregates, but also small areas, typically smaller than what we think of as the regions, or possibly combinations of small areas, such as conurbations or rural areas. So what's the background to this talk? There is increasing interest in measures of well-being as distinct from measures like GDP, which reflect aggregate income or aggregate output. There is a considerable body of evidence that suggests that utility is approximately logarithmic in consumption. It's not exactly logarithmic in consumption. No, I think people suggest that there's slightly more curvature than you would get with a logarithmic function, but it's close to logarithmic. And if you do take the idea that utility is logarithmic, then Andrew Aitken and I showed in an article which came out earlier this year that growth in the geometric mean of household income, adjusted for household size, deflated by a democratic price index, gives a straightforward and easily explained indicator of social welfare. On the one hand, it's the growth in the logarithmic utility function. On the other hand, it can be explained to the public as the average of the growth rates of real income across all households, and that of course is quite different from growth rate of average income. The growth rate of average income has a strong bias towards the upper end of the income distribution. The average of each household's growth rate treats each household's experience equally. Now, there's a question then how to do this for small areas. And you might want to do that either because the small area values are themselves of interest, or you might be worried about aggregating into the sort of flexible geographies that I mentioned. So in this paper, we look at the problems of producing a small area, price index weight. There's, of course, the separate problem of producing small area indicators of individual price movements. Paul Smith at the University of Southampton has done some work on that, and at some stage it may be possible to combine the two, but that's very much a thought for the future. So what is the democratic price index? The appropriate deflator for the geometric mean of household income is compiled using commodity weights, which are the averages of each household's expenditure shares. This was a concept developed by my late colleague Zig Price in 1959, but he didn't follow it through to the welfare side. And these democratic weights contrast with the plutocratic weights used for deflating mean income. The plutocratic weights, of course, represent the shares in total expenditure, the shares of each good or service in total expenditure. Now, if you want to produce small area democratic weights, you have to have some system for spatial interpolation or spatial disaggregation. And you do want the expenditure shares to add up to 1. Now, if you treat each expenditure share independently of every other expenditure share and estimate a separate equation, a separate interpolation equation for each of them, then it seems to me very unlikely that you will get weights which add up to 1. On the other hand, if you want to produce a coherent price index, you need weights which add up to 1. So how can we build on the existing work on small area estimation to deliver weights which add up to 1? Well, most small area work is done using linear models with cluster random effects. So in the equation I've set out here, y is the vector of observations of the variable of interest, I is a vector of ones, x is the matrix of covariates, and beta is the vector of coefficients that map the covariates to the variables of interest. Now, in the sorts of equations that I was used to, we just had a random term epsilon added on. But the typical small area model uses random effects. Here, V is a vector of random effects, and these typically relate to clusters. They can't relate to individual observations because those are mocked up by the epsilon. These relate to clusters such as all the households living in a particular area or a particular region, or they could relate to other aggregations of households. But the logic of the random effects model is that we're saying we want to mop up as much variation across the clusters using the fixed effects, the X terms. Once they've mopped up as much as possible, we'll look to see if there's any further cluster-specific effect, and the random effects model estimates those if they're to be found. So the estimated value of V is orthogonal to the X's because the X's have already mopped up as much cluster variation as possible. Epsilon is a vector of random terms uncorrelated across variables. Now here I assume it to be homoscedastic, but a paper in Econometrica nearly 20 years ago extended the framework to allow it to be heteroscedastic, but I must say I have no idea how you could combine the sort of heteroscedasticity that Elbers and his colleagues looked at and still get expenditure shares that added up to 1. So let's suppose that we apply the model to consumption category J. So here I've written out the sort of equation that we could estimate for consumption category J. And it's a property of ordinary least squares that if you don't have any cluster effects, if Vj is 0, Vj is mapped to the specific clusters by the design matrix Q, so we can't have Q as 0, it's not estimated, it's given by the data structure. But if V is 0, then provided X is the same for all consumption categories, adding up is guaranteed. That's a property of ordinary least squares estimation. So while you might want to estimate an equation like that by 3-stage least squares, there's absolutely no need to do so, simply in order to ensure adding up, and you don't need to impose any cross-equation restrictions. So now let's define Vk as the value of the random term for cluster K associated with category J. And let's also specify the variance of the idiosyncratic random term for observation I. What we can then show is that if the ratio of the cluster random effects to the idiosyncratic random effect is the same for all J, and the equations are estimated by generalized least squares, i.e. you have to know what that ratio is, then the adding up constraint holds. And I suspect it would hold for more complicated cluster structures. You might have an age-specific random variable as well as a geographic random variable, provided the ratio's condition holds. But that's something I haven't been able to prove so far. Anyway, if we put sigma tilde equal to this ratio of variances, we can then write the model in the form that I have set out here, and that can be estimated reasonably straightforwardly. Harville shows how to do that without needing to construct the full matrix, which is inverted. And if you do that, then you can get, then you can also derive the covariance matrix between the estimates, the fitted values for two different categories of expenditure in the way that I've set out here. There are, as always, two sources of covariance. One is from the uncertainty in the model parameters and in the betas, and the other is from the idiosyncratic terms, and those feed through into the system through the ratio. So this expression is likely to be quite useful to us, because if we want to produce a price index, we have to produce a linear combination of the different expenditure shares. If we know the covariance using this formula, then we can work out the reliability of any price index that we can compute. Or rather, we can calculate the variance which arises from the uncertainty in the model that I've described, rather a different thing from the total uncertainty. Now, you might say, how do I get the ratio of the sigmas? Looking back at the previous slide, how do I work out this ratio? Well, if you've got a number of independent equations, you can get a number of independent estimates for it. And what we've done is to produce an average which is weighted by the variance of the estimates of each of the 12 categories of consumption that we look at. You might worry, and I have worried, about the covariances in that ratio, and trying to resolve that, I'm afraid, is a job for the future. But here, what I have done is to set out an illustrative application. It's illustrative because to do this in the manner that is necessary requires access to the the ONS Secure Research Service, while I've been very fortunate, they have been giving access to allow me to continue the work for ESCoE. I thought it would be quicker to develop this out of that secure environment on my own computer at home. So what I've done is to take the publicly available living costs and food survey. What I've done to that is to create artificial small areas by clustering groups of 3 or 4 observations, giving me about 1,100 small area aggregates. That is fewer than the number of middle area super output areas identified by the ONS, but it's larger than the number of lower tier local authorities. So it's a sort of intermediate category. And then what I do is use the average of household net income in these categories to explain the consumption shares in each of the small areas for the 12 consumption categories. What I do is to fit the model across the standard regions of the UK with region random effects only. So there are more random effects you might want to put in, and ideally you would run it with LTLA or MSOA random effects, but I haven't been able to do that. What I then do is use the estimated consumption shares for each region to give weights together, to weight together the price movements shown for the 12 consumption categories, and this gives me regional inflation rates. But of course, I actually have those that I can compute from the data, and a combination of those borrowing strength from the pattern between income and expenditure shares is a means of enhancing the reliability of the consumption shares that you would get if you just used the data aggregates. Given that I've constructed pseudo small areas, the results are purely illustrative, and as I say, future work will apply this to small areas as defined on the LCFS in the Secure Research Service, and will give regional democratic inflation measures based on these. So what are the movements in prices? I've done the work on a Koop 12 basis. This table shows how each of the components of prices moved in January 2016 over January 2015. I can't reproduce CPIH in aggregate because I'm using the LCFS, and the version I've got isn't consistent with the aggregate consumption patterns that the ONS identifies. They do have a version of LCFS in the Secure Research Service which is consistent, and I will be able to work with that. So what do we see about regional spending patterns? Well, perhaps one of the striking things is how similar they are across the different regions. You do see some material differences, perhaps for some of the smaller items. Different regions in the country seem to have different drinking habits, but perhaps the most striking variation is housing. So you can see that in London, people spend 23.5% of people's consumption goes on housing. In other regions like the East Midlands, it's only about 19%. And of course, that reflects the fact that the price of housing in London is considerably higher than elsewhere. You can also see, I show here the standard errors of the shares just from the data, that these shares are actually quite well determined. Here is the set of shares for the second component, the second set of 12 categories of consumption pattern, and as I say, there's rather less variation in these. So then we estimate equations for consumption shares. We know do this, as I say, using as fixed effect the log of the area net income, and then we have a random effect for the regions. Stator gives out the logarithm of the standard of the variance rather than the variant, or sorry, the logarithm of the standard deviation rather than the variance itself. And so from those, I can work out the log of the standard, the log of the ratio of the standard deviations. And I can also work out the standard deviation of the ratio. Here are similar figures for the subsequent 6 categories of consumption. So what values do I get out from this? Well, the top part of this table shows regional inflation rates calculated using survey data weights only. And again here, you can see that these actually seem to be pretty precise. No, the standard errors are shown on the second line. These seem to be pretty precise. You might feel that actually, if you were interested only in regions, you could use them without worrying about enhancing them with small area estimation. But table 7 on the slide shows what they look like if they are enhanced by combining them with the small area estimates, and you can see that there is typically a change of only 1 point in 100, which is certainly not something to worry anyone. There is a gain in reliability, a reduction in the standard error, but it's not actually terribly large. So though this does suggest that the benefits of small area estimation will come if you want to apply this to look at areas smaller than the standard regions, then the sample sizes will obviously be much smaller, and so there'll be a lot more to be gained from enhancing them by fitting the sort of model that I have described. So what are our conclusions and future work? Well, first of all, if you want to produce small area weights, you have to define a model which satisfies the adding up constraint, and that has implications for the sort of mixed estimation that you can do. You can't just fit a separate model to each expenditure share and ignore the adding up constraint. If regional weights are applied at a COE 12 level, then actually the survey data give quite precise expenditure weights, and the gain from using modelled weights in addition to those is small, but that's unlikely to be true for smaller areas. And my final thought, as I mentioned at the start, is that it may be possible to combine these results with regional estimates of price movements to give more firmly based regional indicators of inflation. Thank you very much.
Thanks, Martin, for a great presentation. If people have questions, if you could just, we've got maybe 8 or 9 minutes for questions just now. If people have questions, please put them in the Q&A just now. I guess just maybe a quick one from me, Martin. Is there a sense in which the boosting of the LCFS sample that some of the devolved administrations are doing is going to prove really helpful here, given some of the challenges in small area estimation? So I think the Scottish Government certainly have, I think from 2017-18 onwards, boosted the sample in the LCFS. Is that going to help? And if so, do you have a sense of by how much?
Well, you can see here that in the data set I used, which was the 2015 to 16 LCFS, because I wanted to look at price changes 2016 over 2015, you can see that Scotland's sample was 433. Now, if you doubled that of course, you'd reduce the standard error by the factor of a square root of 2, but actually, no, that would bring your the standard error of the Scottish inflation rate down from 0.03 to 0.02. So if this were all you were interested in, you would say probably that it's not really material. Where the gain would come is that it would help you enhance the accuracy with which you could produce an index based on price index weights for Glasgow, or an index based on price index weights for, well, I was going to say the Highlands and Islands. I'm not sure whether the boost applies through the whole of Scotland or only in the more populous areas.
Thanks, Martin. I don't think there are any other questions at this point, but I think maybe what we should do is move on to Laura's presentation, and we can come back and take questions at the end to any of the presenters, if that's okay. So Laura, could you perhaps share your screen? Perfect.
Okay.
Thank you, Laura.
There we go. Can everyone hear me? Yeah.
We can,
okay.
Yes.
Thank you. Okay, so my name is Laura Requena and I work for the Office for National Statistics for the United Kingdom. And I'm going to talk today about regional estimates, like regional GDP estimates, using administrative data. So this is a paper that the authors that you can see listed there have all contributed. And we all work in the Department of the Surveys and Economic Indicators, the ONS. Okay, so the presentation outline for today is that I will give a brief introduction. I will talk a little bit about the characteristics of the administrative data set that we use. Then I will touch on 2 points regarding the methodology. One is going to be the regional element, and the other is going to be the constraining. Then I will show you some regional comparisons for Wales, and then I will talk about challenges and future work, and then I will show you the original publication. Okay, so then the demand continues to increase for greater granular data. And then there is an ongoing commitment to utilize administrative data sets because they have advantages in comparison to the surveys. So they reduce burden on businesses, and then as well, like they are much cheaper in terms of costs. And the ONS estimates regional GDP for the 9 English regions and Wales. So Northern Ireland and Scotland, they come up with their own estimates. And the first quarterly estimates that the ONS released, they were in September 2019. So we are experimental. The estimates are on its infancy, and we are working on the methodology. And then we are like kind of trying to develop these statistics. And then we have data we publish quarterly, every quarter, and data is available from the first quarter of 2012. Okay, so the data sources that we use to estimate regional GDP could be broken down in 2 components. So we use the administrative data set from Her Majesty Revenues and Customs that accounts for around 70% of data. And then we use what we call the external data sources that accounts for around 30% of the data. Inside the external data sources, we have data sources from other ONS teams, internal teams, and then we have data from other government departments, such as the Department of Education or, for example, the Bank of England. Okay, so the characteristics of the administrative data that we use is that we receive that data at the start of every month. So on the second working of every month, we receive data from HMRC. In that data set that contains millions of records, and we have all of the businesses that they are registered to pay VAT, and then the threshold is they have to comply with the threshold of £85,000 for the last 12 months. So that data set contains several variables, and the one that we use is the total value of sales and all other outputs excluding VAT. And what we do is we use the IDBR, which stands for the Interdepartmental Business Register, and then we map the VAT dataset from, we call it the VAT dataset, the one from HMRC. We map those two things, and then that's how we get the regional information. These, of course, pose some methodological and practical challenges that I will discuss later. Okay, so for the regional element, so if we think about that, we have reporting units linked to an enterprise, then the apportioned turnover for the reporting unit K is given by its apportionment of the using employment. So then we use that at two levels. One is at enterprise and the other one is at reporting unit. So for those who don't like equations, I have a diagram. So if you think about, like, we receive data from HMRC at VAT unit level, and then we map it, and then we sum all of those units that feed into one enterprise, and then we use employment to apportion this down to the reporting unit. So then I have put here an example. So if we can think of like Tesco as a group, Tesco has different kind of departments. So for example, we could have Tesco that they do insurance, they do retail, they do finances, mortgages. So if we think about, for example, the retail component, like the retail part of the group, Tesco has local sites, and if we imagine that we have like a small economy, and then we have a reporting unit of 100 employees with a turnover of £100,000, and then we know because of the register that there are like 5 local units under this reporting unit, out of which we know the employment, so we have here the employment numbers, then we use the proportion, the employment out of the total employment, to come up with the turnover for each local unit or like the site. And then what we do to get the level of the estimate, for example, I chose Wales, what we do is to add all of the different local units turnover for that particular region. And then as well, we could create region industry combinations according to the majority of the proportion, the largest proportion of employment in each site. Okay. So the other component that I would like to explain today is about constraining. So as I mentioned, we published a time series starting from 2012. The ONS publishes regional estimates, annual ones, and rather than, we only go down to NUTS 1, so only like to the regions, but the annual team, they go down to even local authorities, so NUTS 3, and then they have, they publish each December their estimates. So we need to be consistent on the time series where the annual data is available. So what we do is we benchmark the quarterly data to the annual to ensure consistency. And then on the quarters where there is no annual data available, what we do is we use the UK national. And then that's how we ensure consistency across these two, like ONS estimates. Okay. So then on the constraining, before applying any constraining at all, which the constraint applies like from this point onwards, before applying any constraining, the sum of the UK regions might not equal the national total. This is because there are differences in data sources and methods between the compilation approaches, and the regional GDPR constraint to minimize these changes to the region by industry quarterly growth rates. We don't do this by hand. We use the automated balancing tool called FICO Express. And then we have detailed user-defined constraints that I'm going to show you in a second. So this is our objective function. Beta is the adjusted series after the optimization tool is run, so our final output. U is the data before any adjustment has been made. W in the equation represents the weight associated to the particular region section combination. And its value is 1 over the unadjusted value square, to which upper and lower cutoffs are applied to numerical stability. And the purpose of this weight is to make changes to small variables expensive for the software and changes to large variables cheap. So as a result, large variables can be adjusted by a large amount, while small variables will be preferably be adjusted by a smaller amount. This means that in absence of constraints, the size of the adjustments will be proportional to the size of the variables. And then the objective function minimizes the weighted sum of square differences. And this function considers 3 dimensions. So we have the R, which is like stands for regions, industries or sections, and time, which is in this case is every quarter. Alpha and beta are weights to control the importance of each term, and they are currently set up at 0.1 and b is equal to 10. And then a quadratic function is used to spread the adjustments over the terms. Okay, so the constraints for each quarter are very kind of like simple to explain. The UK total remains unchanged, like the national one. As Scotland and Northern Ireland compile their own estimates, we grab them like from their statistical offices. So then UKM, which is Scotland, and UKN is Northern Ireland, they remain unchanged. They can't be altered by the software, and so they are not impacted. Then the sum of the countries in the UK, they have to equal the total. And then we have this component, which is UKZ, which is represents the extra regio, and like to represent any activity that is not done in mainland. And then we have that the sum of the English regions, they need to equal England. Then we have groups, so the sum of all the industries, they have to equal the total. And then we have like groups of industries, so this will represent the manufacturing, and then these like are services. And then for UKZ, we impose a constraint that as these are like oil rigs and offshore activities, they are like the industries there in that kind of region, they are all set to 0 except B and O, which is like public administration and mine equipment. And then so we don't expect to manufacture shoes in the middle of the sea, right? So that's what this is doing. And then the change of the growth rates of the region and section combinations has to be minimized. Okay, so I want to discuss now with you some regional comparisons for Wales. So WSTI stands for the Welsh Short-Term Indicators. So for Wales, the ONS compiles, the ONS calculates like the estimates for Wales, and then we use the monthly business survey plus a top-up survey. So we run this on behalf of Welsh Government. We calculate all the indices and the growth rates, and then we send them to Welsh Government, and Welsh Government writes all the publication. So then, as you can imagine, there are differences that I'm going to show you in a second versus like the way that we calculate regional GDP for Wales, because like of the differences of processes and data sources. So then both approaches cover processing of current price and volume data, deflation, indexation, seasonal adjustment, weighting, and chain linking. These processes are not identical when calculating each estimate, and then seasonal adjustment in WSTI occurs at a lower level at the standard industrial classification 2 digits, rather than at section level, which is the industry totals, and when calculating regional GDP. And then when we calculate WSTI, we don't use constraining at all. So then these are some comparisons for Wales. So for example, for the manufacturing sector, we could see that the regional and the WSTI growth rates, they follow like a similar trend, but there are some spikes that they are due to like the grossing and like some specific companies or like the methods. And then on this one follows like quite a similar trend, while on this one, for example, there are different like parts of the time series where there are like different movements. So this is down like to the data sources and the methods. Okay, so in terms of challenges and future work, so ONS closely monitors any government intervention that could affect the accuracy of the data used to estimate regional GDP. So if you can think of these past months where we had the Eat Out to Help Out scheme, or for example, like VAT was dropped for selected industries. Then at the beginning of the pandemic, HMRC allowed businesses to defer their payment of the VAT. So they were obliged to return the VAT forms, but they could pay next year. And then so we need to keep monitoring this really closely to ensure that the accuracy of our data and our estimates are maintained. And then, as I mentioned, regional estimates are currently published on an experimental basis. So we are still working on the methodology, and we are developing a detailed data sources catalog and a technical report to explain in more detail our methodology. And then we would like to reduce the timeliness of the estimates. So unfortunately, we are with a current lag of 2 quarters. So then our regional GDP quarterly publication is on our website. So please feel free, if you are interested, to have a look. You can click on the green button here and you can download all of our data. So you will find industry region combination growth rates for every quarter, and you have the annuals as well. And then you could select different industries if you are particularly interested, and you can compare them across the different regions. And then as well, you could select a region and then see all the industries. So as well, we have to help the users, we have a section what we called customize your data. So you could select different dimensions to download any data set that you wish for your own analysis. And the last thing I want to mention is that if you are looking for more timely regional estimates, the ONS has set up the big survey, the business impact of the coronavirus survey. So it's a voluntary fortnightly business survey. And this survey captures businesses' response on how their turnover, workforce prices, trade, and business resilience have been affected because of the crisis. And then there are some regional breakdowns provided. And then as well, you have a section of the methodology of how these regional breakdowns are produced. So I have left the link there. And that's all from me today. So I'm happy to take any questions. I have left my email address if you have any feedback or further questions or anything. Thank you very much.
Thanks so much, Laura. That was a fantastic presentation, and nicely to time, like Martin. We've got a couple of questions here. One from Andrew Baldwin, and then one from James Mitchell. So, Andrew, could you perhaps ask your question first? Can you unmute yourself?
Yes, I was interesting presentation, Laura. I was just wondering if this was just a temporary expedient to constrain your regional GDP estimates to match the national quarterly movement of UK GDP. You know, surely the optimal thing in the long term would be to aggregate the regional GDP estimates to form the estimate for the overall UK. Do you have any plans to move in that direction as your regional GDP estimates get firmed up and you remove the 2-quarter lag that now exists between publishing the regional GDP estimates and the publication of the national UK estimates? Thank you.
Thanks, Andrew.
Okay. So, yeah, can you hear me?
Yep.
Yes.
My mic is playing up. So at the moment, like, these are experimental statistics, and we will look like to explore approaches and differences. But the problem that we have, Andrew, is that when we form the quarters, we depend on the administrative data set. So like we will be able to speed like the quarters, like if we only take into account the external data sources. But if we wish to form the national one, we will need the HMRC data, and unfortunately that's with a lag of 2 quarters. So at the moment there is no plans yet to do that approach.
Thanks, Laura. Thanks, Andrew. James Mitchell has a question.
Hi. Yeah, that was very helpful for someone who's been using these new regional data with great interest. But I was wondering if you could say a little bit more, please, about how you handle the constraining on the real and the nominal side? I got the impression that you're sort of doing this separately, but so I was sort of just left wondering whether I should just interpret the difference between the real and nominal as the regional price index or not.
So the constraint occurs at the end of running all the system. So we do deflation before the constraining. So constraining occurs just at the end. So at the end, like once we have deflated and we use the UK GDPO deflators, then we apply the constraining on the deflated data.
Okay, so sorry, that I misunderstood then. So you don't produce constrained nominal estimates then?
No, they are like adjusted, so they are at the end of the system. They are like the ones that you see on the website, right? Those are the real ones, and they are already being constrained. Okay,
but you don't anywhere publish the nominal ones if we were interested in those. Okay.
No, sorry about that.
Okay, thank you.
Thanks, James. I don't think there are any other questions at this stage, but it looks like we'll have quite a bit of time at the end of the 3 presentations for questions to Laura, Martin, and myself. So unless anyone has any questions that come through right now, which it doesn't look like, what I'll do is I'll move on to my own presentation, and we can pick up questions more generally at the end, if that's okay with colleagues. So let me just, okay. So can I just confirm, Laura, you can see my slides okay?
Yep.
Perfect, okay. I just wanted to make sure it wasn't the presentation mode you were saying. Thank you very much for joining this session and for asking questions of the previous presenters. As I said at the start, my name's Stuart McIntyre, and what I'm going to talk about is something which is, since this conference was supposed to take place in person in May, since then actually this paper has appeared. It's a co-authored paper with James Mitchell, who you just heard from, and also Gary Koop, who I know is in the session today as well, and Aubrey Poon. And this is, so this was the work that I'm going to talk about mostly in this presentation has already appeared in the National Institute Economic Review last month. But it builds on a project we've been involved in through the ESCoE umbrella for a number of years now. And Laura's presentation just there was a really useful presentation to have immediately before this this presentation here, because when we first confronted the regional economic growth challenge, if you like, in the UK context, and thinking about the timeliness and the frequency and the historical coverage of these data, what we had was only annual regional data from the ONS for all the NUTS 1 regions of the UK, as well as some quarterly data from the Scottish Government from 1997 onwards, and some data in Northern Ireland and the data that Laura just mentioned for Wales. Since then, things have moved on. So what I'm going to talk about in this presentation is essentially taking the data that Laura just introduced and incorporating those into the framework that we developed for the pre-Rusty. If I refer to, and I blame this nomenclature on colleagues in ONS, but the Rusty data, which is the regional short-term indicator data that Laura just talked about, what this piece of work did was incorporate those Rusty data within the framework we developed to produce more timely, higher frequency estimates of regional economic growth in the UK. So, as I said, those were sort of the 3 challenges that we were, if you like, some of the biggest challenges we saw in the data landscape regionally when we started this project a number of years ago. the timeliness of regional data. So Laura just mentioned there, prior to the introduction of the rusty data by ONS and setting aside Scottish and Northern Ireland data, just focusing on the ONS data, the lag in the release of the annual regional data was about a year after the end of the year in question. So in December this year, we will get annual regional growth data up for 2019. Now, as I said, slightly different for Northern Ireland and Scotland, but I'll come back to that. So what we did in that earlier piece of work was essentially develop a model that allowed us to produce quarterly estimates of regional growth to the same approximate timescale as the ONS produce estimates of growth for the UK as a whole. And we published those on the ESCoE website and have done now since, I think, November 2018. And so that's this point here about addressing 1 and 2 through the previous work we'd done. In this paper, we're looking to try to incorporate, and we have incorporated these rusty data, because this is again another data source and information set about what's happening in the regional economies, as Laura just explained. And what we want to do is incorporate these within the framework we developed on the basis of the annual data. So again, up until 2019 in the data Laura just introduced, all we had was annual regional output data at multiple NUTS levels, so 1, 2, and 3, back to 1997-8, produced by the ONS, with release with a delay of just under a year. This is internationally, this is not uncommon. Certainly across Europe, a very similar issue in terms of the timeliness and frequency of regional data exists. In the UK, the devolved nations, Scotland, who now produce, believe it or not, monthly GDP estimates, and have done now for a number of months, and in Northern Ireland and in Wales through the short-term indicator ONS produce, they've had more timely and higher frequency estimates. But only in 2019 did ONS start producing these quarterly data that Laura just introduced. So having Laura just introduced those, I won't say much more about those, except to make the point that while higher frequency and more timely, there's still a release delay of around 6 months from the end of the quarter. And so again, the sorts of methods and models that we developed when we were just dealing with the ONS annual data still have an important advantage with the rusty data given release delays. And in this paper as well, in order to try to explore what these higher frequency reconciled output data tell us about the operation of the regional economy, in this paper as well, what we did was we brought in data that ONS publish on hours worked in each NUTS 1 region on a quarterly basis, which were published back to 1997. And so that allows us to look at how output per hour worked in each region has evolved over this period. And as you'll see later on when I show you the Scottish data, this really brings out some of the challenges in the differences between methodologies across the UK. So I've talked a bit about the sort of release calendar. I always think it's useful just to kind of show you what that means. So if we take the year 2020, UK GVA, so GDP essentially, ONS colleagues may cringe slightly at that, but I mean, think of it as essentially GDP in this context. For Q4 2019 was released in February. Scottish Government's Q4 data followed in March. In April, we got the rusty data Laura was talking about, but that was only up to Q3 of 2019. It took until July 2020 before these regional GDP that Laura was talking about for Q4 were released. So we're still 6 months before those data were published. So the regional GDP data lag the equivalent UK data by about 6 months. The Scottish data lag the UK data, not by that much now, given ONS is now 6 weeks for UK data, and the Scottish Government have shortened the delay in the release of their data. But this is broadly the release calendar that we're looking at. So this is what we reflect later on when I show you our work on real-time nowcasting. We're reflecting the release calendar that you can see on the screen just now. So what we're doing in this paper is taking that earlier paper we referred to with our initials as KMMP, which is essentially a mixed frequency VAR model, vector autoregressive model. And what that's doing is that's modeling a set of time series variables observed at different frequencies. So in our case, the mixed frequency aspect of that original model arises because we have quarterly data at a UK level and annual data at a regional level. Now, of course, in the model in this paper, we also have, for some of the period, we also have quarterly regional data. And so we need to extend the model to do that. We also have within this framework some additional quarterly macro predictors, which experimentally we found to be useful in explaining sort of intra-year regional growth dynamics. So this framework in KMMP, for those that are familiar with this sort of literature, is a state space VAR of the Shore Friday song type, if you're familiar with that literature. Now, of course, that mixed frequency VAR has the VAR, which is modeling our observed and unobserved quarterly data. So we have observed UK quarterly data for the entire period. We do not observe in the KMMP model the quarterly regional data at all, but in this model we do from the period from 2012 onwards. We've got the rusties for every region and nation of the UK. Now, a couple of other features of the model which are important to talk about. First of all is we add an additional measurement equation to the standard setup here, which we call it the cross-sectional restriction. And what this does is essentially ensure that our regional growth estimates aggregate up with a small error to the estimates produced by the ONS for the UK as a whole. And this small error, partly reflects measurement, statistical discrepancy, but also the activities of the UK continental shelf that Laura talked about. In essence, what we have to do within this KMMP model, once we incorporate the quarterly regional data from 2012 onwards, is redefine this cross-sectional restriction and the measurement equation within the model. So we're adding in these rusty data for the English regions and Wales, as well as the data from the Scottish Government for Scotland and NISRA for Northern Ireland. Again, we are reflecting, as we did before, the release timings. We are having the cross-sectional constraint subject to the caveat I just mentioned. And also, before we have the rusty data, we also make use of an intertemporal constraint, which essentially means that our quarterly growth estimates constrain to the ONS's annual published data for each region. So in this paper, what we're focusing on is 3 key empirical exercises. So first of all, what we want to do is incorporate these quarterly regional data into our model, make the adjustments I've already mentioned, and then compare over the full sample period from the 1970s to 2019, how adding this additional regional information on regional growth in the UK from 2012 onwards changes our understanding of the path of regional growth, subject to all the constraints I already talked about. We're then going to use those data to explore what these output data combined with the ONS's hours work data tell us about the path of regional productivity. And finally, we'll undertake a real-time nowcasting exercise, which is going to essentially have a rolling window of data being available, where we're going to estimate the model sort of quasi real time, and evaluate the performance of this model with the quarterly regional data against the model without. So just by way of a summary of results, in case I can't, I run out of time to go through them in too much detail. In essence, probably reassuringly, as we'd hope, incorporating these data within our model does change our output estimates a little bit. Doesn't hugely change the pattern across most parts of the UK. Perhaps unsurprisingly, the biggest changes are in Scotland and Northern Ireland, because those data are produced differently to the ONS data. So it's probably not a surprise that when we incorporate this new data source, we see more of a change. Secondly, when we look at the implications for regional productivity, we see that there are some differences, and indeed because of the differences in our understanding of regional output, we can actually see quite different economic narratives appearing for particular parts of the UK, depending on the output data that you use to construct those productivity measures. And I'll show what that means. And of course, as we would certainly hope in this sort of environment, adding in these rusty data allows us to produce more accurate nowcasts relative to our original KMMP model. So with all of that, I'll show you some figures here. So this is, I've one for each NUTS1 region of the UK. These are just plots of the output estimates produced with the original model, the KMMP model, that's in blue, and the brown colour is the output estimates from our model incorporating the quarterly data produced by Laura and our team for the English regions and Wales, and from the Scottish Government and Northern Ireland Statistics Agency for Northern Ireland. And what we can see is for most regions, there's high degrees of consistency between the two sets of estimates. If we do simple correlation coefficients, you're looking at estimates between 0.94 and 0.99. So it's a high degree of correlation between the estimates produced by both models. The exception to that is Northern Ireland, where the correlation coefficient drops a bit to 0.89. And also you can sort of see down here with Scotland, again, just visually, we're seeing more change in these estimates. Again, that reflects the fact that actually, if you look at the raw data produced by the Scottish Government and the ONS for Scotland in real terms, and we show this in the paper, they are different. And there's a number of methodological reasons for that. If we turn to some of the other regions, you can see a very similar pattern. Again, most of the differences that we're seeing emerging are after the period where we've got these rusty data. There are some sort of, for the most part, relatively modest changes in the historical series relative to our benchmark model. And that just reflects updated parameter estimates from estimating the model with this additional information in it. So again, it seems as if adding the quarterly data does change somewhat the estimates here, but for the most part, across most regions, they are broadly consistent. And that goes back to Laura's point about the way in which ONS construct their data, their quarterly data. So I said earlier, one of the things that we're keen to do was to say, okay, we can produce quarterly output estimates for all the NUTS1 regions of the UK. But one way of exploring what these suggest about economic performance is to think about what they imply about productivity growth. And so what we've done here is we've produced an output per hour worked series using the estimates I just showed you, along with ONS's data on hours worked by region quarterly. And what you can see immediately from this is that doing so suggests that Scotland has by far the fastest productivity growth over the period since 1997, and Northern Ireland by far the weakest. The UK comes through the middle here in that sort of burgundy line, and you can see quite a lot of regions and parts of the UK seem to have over this period had productivity performance broadly in line with that of the UK as a whole. But Scotland and Northern Ireland in this, this chart clearly look like outliers. Now, one of the things that, conscious slightly of time, so I won't talk through all these results, but one of the things that, of course, if we're constructing an output per hour's work series, there's two components of that. The first is output, quarterly output, and the second is quarterly hours worked. And so what we can do, and we do this in the paper for the different regions, is plot the components here to try and understand what's happening. And so if we look at this GVA index, so this is our quarterly GVA index based on the ONS data for London. We've had a period of pretty rapid output growth, the financial crisis, and then essentially a return to something close to trend output growth. But at the same time, when we look at hours worked, which is down the bottom here, the sort of dashed line, we're seeing throughout the period in the run up to the financial crisis, growth in hours worked in London was pretty flat, but post the financial crisis seems really to have picked up. The effect of this is if we look at this solid black line here, that actually post the financial crisis productivity growth in London was pretty flat. Now, for time reasons, I'm not going to interpret the table on the right, but what I do want to do is focus a bit on Scotland, because I mentioned earlier that the data for Scotland was slightly different to those for Scotland produced by the ONS. And essentially what that shows is this solid line at the top is output in Scotland based on ONS's annual data. And this dash series here is just a plot of the quarterly Scottish output data from the Scottish Government. And you see over this whole period, again, this is an index, you can see the Scottish Government's data suggests that output has grown not as quickly in Scotland as the ONS estimate it has in Scotland. Now, if we look at the hours work data at the bottom, the Scottish Government in their productivity series do a bit of smoothing, but in essence, the hours work data the Scottish Government use for their productivity data and those reported by the ONS are basically the same. So all of the difference when we start thinking about differences in productivity growth, so this is this line up here is productivity growth using ONS data and our model, and this is down here productivity growth as reported by the Scottish Government. And so these differences are purely being driven by differences in the underlying output series. So even once we incorporate Scottish Government series, our estimates are still for faster growth than those reported using the Scottish Government methodology. So I think it's quite nice we can explore these issues. We can also, as I talked about earlier, we can also do a real-time nowcasting exercise because the Rusty data only go back to 2012. Oh, sorry, my iPhone picking up there. Because the Rusty data only go back to 2012 quarter 1, that's when we start our out sample evaluation in 2012 quarter 2. So again, what we're doing here is we're estimating our model with an expanding panel of data. Now, we don't have a data set because the Rusty data were only first released last year. And so we use, in the paper, the latest, which at the time of writing, it was the February Rusty data vintage. Now, one of the things that is worth flagging up is that because of the release delay in publishing the Rusty data, which is about 6 months, we actually have both we have two, when we get the UK data, we do not have the Rusty data for the 2 previous quarters. So when we get Q3 UK data, at that point, we don't have Q3 or Q2 regional data at that point. So if you go back to the release calendar, when we get UK GVA data for Q3 in November, the latest regional data we have is for Q1. And so we've got 2 quarters that we want to estimate here at a regional level. And we refer to that as the nowcast. So in the case of Q3 here, that nowcast would be of regional growth in Q3, and the backcast would be the estimate of regional growth in Q2. And we evaluate both. And what we do in the paper is we report both the cumulative log scores, so looking at the entire predictive density, as well as the point estimates with root mean square forecast errors. Aware that I'm well over time at this stage, I won't linger on these too much. I can show them some more if people have questions. But in essence, what you can see very clearly here is that in both cases, particularly with the log scores, incorporating the Rusty data leads to appreciably better estimates, both of the same quarter and the previous quarter, so the nowcast and backcast of regional growth. So just to conclude, again, conscious I'm over time. What we've done in this paper is try to reconcile the fact that we now have not just the annual estimates from ONS, but also quarterly estimates from the ONS, as well as quarterly estimates from the Scottish Government and the Northern Ireland Statistics and Research Agency. So trying to combine these quarterly data within our original model, I think we've managed that quite successfully. The evaluation that I showed you suggests that we're seeing appreciable improvements in forecast, nowcast and backcast accuracy. And it also opens up the ability, as we showed in both papers, to start thinking about some really interesting regional economic questions around things like productivity, but also the regional business cycle, which is much more difficult to do with annual data for obvious reasons. I think in terms of sort of next steps and where we're going with this, I think that there's a number of really interesting questions in this space. It's great that ONS are now producing quarterly data. The differences in methodologies between the ONS and the devolved administrations, I think, is something that I know colleagues are thinking about, and I think that's quite important. Also, just as a more general point, and I know talking to people who are using the ONS data or using our estimates, there's a lot of interest and appetite in going below NUTS 1, given increased devolution of economic policy. We're seeing city-region deals, combined authorities, local enterprise partnerships, etc. And again, just taking the sort of more timely estimates that Laura talked about and that we are producing, taking these to higher levels of spatial granularity is something that I think would be really interesting and really exciting to do. And hopefully through the work we've done at NUTS 1, we're able to highlight how useful these data are and can be in shedding light on the performance of regional economies. So with that, I'll hand back to Martin, who I think is going to chair the final Q&A part. I don't know if there are any questions that have come in, Martin.
At the moment, we don't have any questions. I'd actually like to ask Laura a question, please. So, Laura, you said that you used VAT data as the basis of your quarterly measure. And my question was how you handled the staggers in the VAT data. That some people reply November for 3 months, November to January, others for 3 months, December to February, and yet others January to March.
Yeah, so we have, like Martin, different methods on the VAT system that handles all the different staggers. So then it depends on how how the businesses return. There is a different method that is applied to come up with a monthly that then we aggregate. So it depends on the stagger. But
my question is exactly that. How do you come up with the monthly?
if they do not report monthly?
Well, that most people report for rolling 3-month periods.
Okay, I will look for, there is a paper with the methods that they do that, so I will forward that to you, which explains that in detail.
Okay, well, I'm interested in that because the work I've done with Paul Le Bon on the use of VAT data has focused entirely on how you create monthly data from the rolling quarterly data.
Yeah, I will send you the paper with all the specifications.
And now a question for you, Stuart. Is there a further range of indicators that you could use to enhance your data? No,
Yeah.
I mean, have you used things like VAT returns?
No, we haven't used the VAT returns. One of the things that we did in the earlier, the KMMP paper I mentioned earlier, was we experimented with different regional indicators within the model. So at the moment, as I said, there are additional macro indicators, but they're UK macro indicators. So what we did was we added in some labour market data and also some survey data from the CBI that we could take back to the 70s, neither of which radically changed the results. You know, the information content I don't think was that substantial within those indicators. The thing about the VAT data, which is, it'd be great, I think, to incorporate the VAT data. The challenge we've got, and I think this is partly reflected in the fact that ONS have only been able to take the rusty data back to 2012, is just working within these sorts of time series models, having a relatively short span of data available is quite challenging. If we only have VAT data available from 2012 onwards, you know, it's how we do that. I think as well, one of the things that I know we've talked a bit about is just if it's the case that the rusty data, as Laura explained, essentially based on those regional VAT data, we'd be looking within a sort of time series framework to have the sort of aggregation that Laura produces. Now, one of the things we could try to do is use the sectoral disaggregations that Laura produces within the model. But in all cases within our sort of framework, we'd want to have some aggregation of these VAT data within the model. So we could try and do that ourselves, but with the might of ONS producing and pulling the VAT data together, I think the best thing certainly is to work with the rusty data and the VAT data by extension.
Yes. Okay, well, thank you,
Martin, can I go back to you on so you were interested on the ones that they report for 3 months, right? Did you ask for that case specifically?
Yes, well, I think the answer, no, 90% of the returns cover a 3-month period, but they don't all cover the same 3-month period. That was the problem that Paul and I addressed.
We use the survey. We use the survey data, which is not ideal because we like to stop the surveys at some point, but we use the survey data to inform the pattern, to break down to monthly.
I see. So you enhance the VAT data with the survey monthly pattern. I see. Okay. Yes.
Does that answer your question?
Well, it certainly does. Yes.
Okay.
Yes. So, are there any further questions, please? Any of the attenders do you have any questions, please?
If people want to maybe just take a minute or two and just see if there are any other last questions. I mean, one of the things that I guess I was going to sort of add at the end of mine, but I didn't because I was aware I was well over time, taking advantage of you, Martin, and Laura being absolutely to time, indeed under your time. If you go onto the ESCoE website, we've been reporting every quarter since the end of 2018 in real time our estimates of regional growth. And of course, in the time of COVID, that's incredibly challenging. And we're not alone in there's been a number of papers that have emerged in looking at how growth of, or the economy contracting by 20% in 1 quarter plays out within these sorts of models, and some really interesting papers on that. One of the things that we found was, and you can read the blog on the ESCoE website about this, is it's essentially, it proved problematic in our model as well, just to run the model as we ordinarily would. And so we've done a bit of work just trying to explore different ways of generating regional output estimates that, at least economically, make more sense in a time when these sorts of models struggle with the economy contracting by 20%. So if anyone's interested in how our model reacted in light of COVID, please check out the ESCoE website.
Okay, well, thank you. Now we've got a question from Andrew Baldwin. Please, could you demute him?
Thank you very much, Mr. Weale. The Russian Federation, when it established a national consumer price index, estimated it from the beginning based on a rectangular matrix of expenditure weights with regions as columns and goods as rows. So the regional CPIs would properly aggregate to the national CPI. The Canadian CPI came to be calculated based on a rectangular matrix before that, but only after many years when the regional CPIs did not aggregate to the Canadian national CPI, which made users of the statistics unhappy. Does the ONS have any plans to calculate the UK CPI this way in future? If we were going to calculate the UK CPI this way, the disaggregation of regional CPIs to include city indices should be treated with caution. In the Canadian CPI, some of the early regional city CPIs have been dropped. Only the Toronto and Vancouver regional CPIs remain. Even Montreal, the second largest Canadian city, no longer has its own regional CPI. So is there really a strong case for a regional CPI for Glasgow? Thank you.
Well, I mean, since I had raised the question of a CPI for Glasgow, I'll assume that that's a question for me. I think, I mean, whether one would want a CPI for Glasgow rather than CPIs on a regional national basis, i.e. Scotland, Northern Ireland, Wales, and the regions in England, I'm not sure. But there is certainly, periodically we hear comments that the unobserved price experiences of different parts of the country are very different from the average or from the national experience. Now, when no one knows whether that's true or not, it's a bit difficult to respond. So I think there is a case for having regional and sub-regional statistics on a regular basis, so as to at least to be able to answer that question. As I say, whether that would extend to a CPI for Glasgow or just a CPI for the central belt of Scotland, I think at this stage isn't clear. Now, we also have, is this a question from Anna?
Sorry, it's because Stuart started divagating about the impact of the new data, right? The one that looks like an outlier on their modeling for getting the regional data. So I'm very curious about his views on that.
Yeah, I mean, you'll probably know this in some of the papers that I'm thinking about that have been looking at this issue at a national level over the last few months. We've done a bit of experimenting with trying to use sort of methods around fat tails, essentially, to try to
this, right?
Yeah, exactly. Now, what we ended up doing, just partly pragmatically, given where we were at and wanting to produce something, that wasn't a 2-year research project, was we used entropic tilting to produce conditional estimates. So we basically ran our model up to the end of 2019, and then conditioned on the UK data for Q1 and Q2 to produce their estimates for Q2, and that produced results that at least economically seemed much more sensible across regions. But one of the things that we are thinking about and trying to incorporate is some of, is there something with these new methods or that we could extend into? Always, as you'll know with James and Gary, conscious of new interesting academic questions.
It's a very cool academic question, because what you did is basically saying, look, I don't want these big changes to affect my coefficients.
Yep.
But still I want them to inform my measure, but then you don't know which modeling would be better to allow that. If you need to add stochastic volatility distribution, or if this is a one-off and you treat as an outlier and it'll be fine.
Yeah, I mean, yeah. Sorry, Martin. I think I was going to.
No, I was going to say we've also had really an observation from Jagdeev noting that the ONS produced initial estimates in 2010 and then they stalled. But I wonder if we could finish up with the question from John Galbraith, please.
Thank you. Can you hear me?
Yes, thank you.
Thanks. Thanks to everyone for a very, very interesting session. And I have a quick question for Stuart. I wonder if you've thought about using card transaction data to get real-time estimates of consumption by region. If you have sufficiently detailed data, of course, you can get a lot of information at a very granular level, but getting access to those data is, of course, always a challenge.
Thanks, Sean. Yeah, I think that's a really good point. Now, there's been some work that I've seen, particularly in Spain with BBVA bank transaction data for nowcasting more at a national level. Although the richness of that data means they can actually use that to sort of to quantify economic activity at a really granular level, because they know exactly whose card it is and where the transaction takes place, etc., etc. From the point of view of our sorts of models, where this runs into some challenges is around the shortness of the time series that typically we've got for these data, and how we collapse what is a massive data set into indicators that speak to our sort of regional or sub-regional setup. So there's a step before that. Even if we had a longer time series, what we'd probably want to do was a step before collapsing these down, a bit like the ONS have done with the Rusty data, of taking the VAT data, producing from that a smaller number of indicators, which can then feed into the sorts of models we're working with. So it's definitely possible to do something like that, and there have been examples using those sorts of data. Two challenges. One, as you mentioned, data access. ONS colleagues I know have been working, I think, with Barclaycard through the data science campus in the UK to try and do something on that. But the other issue is just that issue of time series. And it's likely that we would have, it's not impossible, we might have some challenges in incorporating data where there's a relatively short time span of data available on these sorts of measures within our framework.
Thanks very much.
Okay, well, thank you very much. I should bring the session to a close now, but many thanks to all of the, to the other speakers and also to all of the other participants in this session. So we've got a break of half an hour now, and then the final panel session. Thank you.
Thank you everyone for attending.